Okay, let's look at question 7. So at a carnival, each child is entitled to 6 coupons, while each adult is entitled to 2 coupons. So there is a total of 75 people at the carnival. Given that the total coupons that the children received is 210 more than what the adults received, how many children are there at the carnival? Okay, so we know the coupons, the number of coupons for each child, each adult, fair enough. We know there are total 75 people, but out of these 75 people, I do not know how many are children, neither do I know how many are adults. Okay, so some of you will say, oh, maybe let's do guess and check. Well, guess and check works, but not always the most time efficient, right? So, and also they have given us the total difference in the coupons between all the children and all the adults. Okay, so I know this seems like a grouping question, but actually it's not grouping. You only use grouping if the question has given us a clue on the proportion of children and adults. Okay, for example, if they say there is equal number of children and adults, or if they say there are twice as many children as adults, something like that. All right, then probably grouping might work. But in this case, no. The 75 people, the quantity here, I know nothing. I only know there's total 75 people, that's all. All right, so this question, in fact, is using the supposition with difference method, which is something that we have covered in class last lesson, if you recall. Okay, the last lesson one, I think we used something similar about the boys and girls, the tickets question, if I didn't remember wrongly. Okay, so supposition with difference, which is one of the harder tiers of your supposition concept. So I'm just going to label out first. So each child has 6 coupons and each adult has 2 coupons. Now, we're going to start off with assuming all are something first. Okay, are we going to assume all are children or all are adults? So typically, I will look at this sentence first, the more than part. Okay, I use this as a gauge. Based on this sentence, I know that all the children received more coupons because 210 more by the children. Okay, so those who receive more, I will start off with assuming with that group of people first. Let me see if the children receive more. I start off with assuming all are children. So for the normal assumption question, we always assume the opposite of what the question wants. If they ask for children, we assume all are adults. But for this supposition question, we start off with assuming those who already have more items, which is the children in this case. Okay, now if I assume all are children, that means I pretend all 75 people are children, and that means there are 0 adults. So which means that between children and adults, there will be a huge difference in the number of coupons, because 0 adults also means 0 coupons for the adults. 75 children would mean, I don't know how many coupons, we need to work that out, many coupons. So between these 2 groups of people, it will be this thing called the total difference, which we need to calculate out. The total difference in coupons between those 2 groups of people. And this is where we have a little graph here to show you, to illustrate what's going on. So I strongly suggest you draw this out. So since I assume there are 75 children, I'm going to draw a very huge graph. This is 75 people, 75 children, but 0 adults. So adults, no graph, nothing. Okay, and I'm going to go on to calculate out what is this total number of coupons by these children. And this also acts as the difference between the 2 graphs. So simply taking 75 children, multiply by 6 coupons per child. So this is 450. So that means 450 is also the difference between the children and adults at this point, based on my assumption. Okay, now, but the thing is the difference between these 2 groups of people really 450? So if we read back the question, remember what I underlined here. This was the real difference. The children has 210 coupons more than all the adults. But based on my assumption here, the children has 450 more coupons than the adults. So obviously my assumption is not true, it's just assumed only. Okay, so our goal now is to slowly narrow down this difference to 210, which also means this difference is too large. I need to find out what is the difference to remove away, to narrow down, to remove off, so that I can reduce it to 210. Which means the next step, we call it difference to remove. Okay, so imagine the difference 450, you are going to shrink it. You're going to slowly shrink it, okay, make it like smaller and smaller until there's a smaller difference of 210. Okay, so simply by taking 450 minus 210, this is the difference to remove away. Now, to remove away these 240 coupons difference, it also means that I need to compress the children graph and I need the adults graph to rise. I need it to increase, to grow. Okay, only by compressing this and by growing this one, then I can allow the difference to narrow down. I hope you all agree with me on that. Okay, and by doing that, in that process, we are actually also performing what we call one exchange. That means we are exchanging a child to an adult. So supposition is always about performing an exchange. Okay, so for the children graph, now when I exchange a child to an adult, that means I take away a child. And when I take away a child, this graph, it will start to compress. It will start to shrink in size. And that means the graph here will drop. Okay, so my question is drop by how many coupons? So since I'm taking out one child, since I'm performing one exchange, right? I take out one child, that means this graph will drop by 6 coupons. Now, since I take away a child and I put in an adult, that also means this adult's graph will start to grow in height. And when it grow in height means it will grow by 2 coupons because every adult has 2 coupons. Okay, so this is how one exchange looks like. So this will continue, dot, 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 dot. All right, every time I perform one exchange, this is now the new difference between these two red dotted lines. After every exchange, this is the new difference. So I hope you can tell that the difference has now become smaller. Just now the difference was 450. Now the difference every exchange, after every exchange, the difference now become this size only between the two red lines. Okay, so this is what I just said. In every exchange, there is a drop in 6, but a rise in 2 at the same time. So that means every one exchange, what I've done is I've removed away this difference of 6, and I've also removed away this difference of 2 to allow the difference to narrow down to between these two lines. So what I've taken away, is 6 and 2, which is a 8, difference of 8. I've removed away difference of 8. All right. Now, of course, one exchange is not enough because remember, altogether we need to remove 240. So the number of exchanges will come in, which is by taking 240 divided by 8 to find out there's 30 of such exchanges taking place. And 30 exchanges also means I have 30 adults in the end because every exchange I change from a child to an adult. So 30 exchanges also means 30 children to become 30 adults, to change to 30 adults. Okay, now read the question again. How many children at the carnival? So this is only adults, we don't stop there. Number of children, how to do? Remember you have total of 75 people. So you just need to use your 75 people minus away the 30 adults.